Good morning. Today we fight CUDAGraphs. Let me show you where we left off, because I did fix one thing. We're not doing the LLM bullshit stream today. That will be sometime in the next week-ish. We have to fix CUDAGraphs first. I want to make sure we have one thing at least done. Let me show you what I've been working on. Okay, so every single LLM missed this, by the way. You have to restore the old stream at the end. One line bug. Completely unreadable error message. Welcome, Pepe. So yeah, with this now we can actually run it. The issue that I'm having at the moment is, so this state buffer out, this gets populated correctly, I've tested it, but for whatever reason, this does not seem to be consuming and using state correctly. So yeah, that's kind of weird. Let me see if I can remember how I was testing this. I believe it was, if I just rebuild. I believe we're going to get at least 1 mil SPS off of the eval loop from this. And then we can probably get more when we apply to train in the optimizer. I think it's also, this is only going to be hard once. Like, once I figure this out for one chunk of the network, the rest is easy. I have all day today. Okay, yep. So what this is showing essentially is the output of the buffer is always the same. So if I just look here, the idea is that you have the state input, and then Puffer copies it in, and then it replays the graph, and then it copies it out. And I put these syncs in here just to make sure there's nothing async weird going on. And then I look at the first item of the output, and there's nothing there. And I've tested that this buffer is outputting correctly. Like, you can set stuff in the loop and it works. So I believe that somehow then the network is not like using the state in a reasonable way. Doesn't make a ton of sense to me. Like, we get the state out from state input here. Actually, hang on. It's getting sort of set, right? How does it get the 0.25 in it? Is it just like a steady state thing? Maybe 0.25, it's like an attractor. How do I test this? Let me think. Well, I can just do the, hang on, I know what I can do. We can test this versus the previous implementation, right? Which is this one. Then we do state out first item like this. Okay, so this is what happens when I use the real network. We can see we get 0.25, but then it actually changes, right? And it evolves. So there is actually a problem. So how is it then that this, is it not getting fed back in correctly or something? Like, that would seem odd to me. I was trying to figure out if I could get this done off stream in the evening last night, and I fixed the one bug from before, and I just couldn't finish this one. Okay, so this is saying that the first item is 0, and then the first item is 0.25, right? So how then graph state? This never gets overwritten, right? I hate these autos. That's what it's gonna be, man. We fight CUDAGraphs today. I'm gonna do a stream like in the next several days because Carpathy tweets it like fine. I strongly, strongly suspect that the guy is like, I don't know, he's like done all of his stuff and now I don't know. I'll be shocked if it's actually good. And of course, when Carpathy tweets shit, like every motherfucker like just jumps on it to justify them being lazy and not bothering to learn anything. I could be dramatically wrong, but so far the models have been worse than useless. I solved a couple of the problems from yesterday off market. Now there's just something weird going on with the traced graph, but we can run this traced graph stably. I'd like to be less mad about all the LLM stuff, honestly. I'd like to just be able to like, chill and ignore stuff and being clear of mind to just focus and create like awesome stuff. Um, but for whatever reason, it's like a lot of the stuff I build out of spite most of the time. So I don't know if I'm capable of just chilling and building all this. So, meh. It bothers me though. It bothers me. What could this be that, like, we know that this, well, actually, I can't even print this out though, can I? How do I test this? You know, I have an idea. Here's how we can test this. We're going to add 1 to the buffer, and we're going to see what happens to the output. Plus 1, like this. If it outputs every time, then it's not getting copied to the input. Like if it still outputs 0.25. Huh. There's no way it maps every output to 0.25, right? Because I guess that would also do it. Let's do a pass through real quick. Yeah, I said I'm gonna do, I'll do a stream. I have a project in mind that would take me like a few days. Um, I'm going to get, so what, let me be clear. When I do this, I'm going to give it a genuine attempt. Like, I'm going to set it up in the best possible way for it to succeed. So nobody's going to be able to say, like, oh, you just designed this in a way to fail or you didn't do it properly. Like, I'm going to be very clear about it, but I do not have high expectations for this. Like, honestly, the most likely scenario in my head is just that everybody really likes when these models tell them how good they are at coding and how smart they are, and they like feeling super productive even though they have no idea what they're doing and they're just building complete and utter bullshit, and in the process actually not bothering to even understand things that would allow them to learn and build things that are useful. I think it's just laziness, sycophancy, and general idiocy. That's my guess. I guess it's technically possible that one generation of models like happened to be the huge leap, but this is what people have been telling me since GPT 3.5. They were shit programmers that didn't know what they were doing back then, and I'm almost guaranteeing you they're shit programmers that don't know what they're doing now. Which is pretty impressive as well coming from me, because like I am nowhere near skill capped. Like I could be 10 times better than I am now. Not like with LLMs at all, just straight up be 10 times better at what I do. But honestly, for me, the biggest, I think the best thing that I could do is if I could just figure out a way to consistently have more energy for my work, that would be bigger than anything else. Because I really like my work, and mostly the cap for me is I just get burnt out by all the stuff that I deal with. And stuff like this burns me out super quick. Like, I sat down yesterday. Why the heck did I need to take a week and a half vacation? I never take that much time off. And then I sit down and immediately I go, oh, this is why. You know? I don't know if they will just by scaling them, man. I wouldn't be surprised if they just don't under the current paradigm. Like, they're going to be useful, they're going to be valuable. But like the whole concept of like, let's just offload our thinking and abstract away everything to a model is just fundamentally stupid to me. I would way rather, like, these models are designed in the laziest way possible. Let's say that we got genuinely smart models, okay? Like, assuming we have not completely just replaced all of humanity, then what I would like to have is I would like to have something that actually feels like a smart assistant, not like just doing shit for me, right? Like if I could just get the answer to every niche technical question I have, not like how do I do this piece of logic, but like every niche technical question I have, with perfect accuracy or at least with verifiability, like that would be way more useful than something that like kind of spits out a bunch of code but then gets it wrong half the time and like misses basic stuff. Like there are ways to make these things useful, but it's not the direction that people have gone in. Like it's essentially the dumbest, laziest, like most idiot-prone way of using these models has become the default. And I don't feel like building that type of stuff either because I have other things I can be doing that I feel are more valuable, right? Like I think RL is going to be as important, if not like more important long term than language models are. It's not going to be the super flashy type of a thing, right? It's not going to be the super sexy stuff that you hear about, but it's going to be everywhere. Okay, so look at this, right? The input and the output buffers are working correctly because otherwise this would not work properly, right? Because this gets incremented by 1. Ooh, wait, hang on. Shouldn't it get incremented by 2? Hmm. Let me just, let's double check one thing here, which is going to be... I'm a little suspicious of this. Okay, yeah, it actually, I think, is fine. Because before it double, yeah, that's fine. Okay, so the reason that I did this is I wanted to make sure that the input and output handles did not get messed up. Because if you mess up the pointer somehow, the way that this tracing works, right, is it replays the exact operations on the exact memory addresses. So these pointers have to not get messed up. So let me see what this maps to. Honestly, I hate to say it, but like kind of Carpathy. Like there are other people that hyped it up, but he was the most legitimate person that hyped all this shit up. But like Carpathy has always had split takes, right? He's done some like Carpathy has always been the type of guy who's had some absolutely amazing stuff and then some absolutely stupid stuff. Like I remember back when he was a PhD student, one of the things he said is that he didn't want better programming languages, he wanted better IDEs. I still remember that back from when I was like 16 or 17 at most. It's like, what the hell? Why? And like, maybe I just don't understand it. And today I'm still thinking like that's like crazy. Honestly, the stuff from Carpathy that I like the most are all of his not his like takes on stuff, right? I like his simple implementations and explanations of stuff. Those are world class and fantastic. And also, a lot of his research from when he was a PhD student as well. Like when he was doing active research was awesome, right? Also, like his teaching stuff was amazing as well. So I'm still a big fan of the guy. I mean, there are very few people that I have more respect for, and even if it is the case that this ends up being completely stupid, I'll still have a ton of respect for him, right? Like, because he has all this other stuff. Educator. See, I don't think that that's fair though, because like if you can build simple stuff, that's not just educational. That is how you build world-class software. That is how you take hard problems that are opaque and that like nobody can understand and cannot advance, and that is how you actually bring them into the light, right? That is exactly I am doing that with Pufferlib. That's my goal. And it's not educational, right? It happens to be the case that there's overlap where doing this, it makes it more accessible and also like it brings people into the field, and that's awesome. But like that wasn't even my primary goal starting Pufferlip, right? It was to make RL actually work at scale. And it's just that in my mind, the way to do that is you take something very complicated, you make it very simple, and then you can understand it fully. And that is a way better base to build off of than just saying, ah, screw it, we're gonna go fast and we're gonna like, chuck a bunch of stuff at the wall and not actually having any sort of observability about what you're building. Because I've heard that take from other people before, and I don't think that that gives Carpathy anywhere near enough credit. Yeah, if I don't build Puffer, literally nobody will do this. RL will continue to suck, and this awesome technology that is straight out of sci-fi that we have seen proven will just not be there. It will not be there in a form that you can easily use or in the form that it should exist for possibly decades, possibly ever. That's something that I had to learn during my PhD. During my PhD, I thought I would stop building neural MMO after a couple of years because I figured that DeepMind would just go like see what I was doing, build it. It was a pretty obvious next step to do, but instead they hard trolled. They did a bunch of projects that were infinitely dumber in their direction with way more resources, and nobody else remotely did the obvious thing. It is literally the case, right? It's not the case that there are a room full of scientists working on every hard and important problem out there. It is literally the case often that if you are smart and have an idea, if you don't do it, it will not exist. Nobody will do it ever, and it just will not be something that is available in the world. So, like, I guess in some sense, just the amount of ineptitude I see around me, it's very disappointing because, if people thought this way, like we would live in a dramatically better world. But at the same time, given that we live in the world that we do, like there's a huge amount of opportunity to build stuff and to improve upon things. The thing is, you're fighting upstream a lot of the time because the default way that things are done and the way that things are set up for you to work is fundamentally wrong, right? That is the reason most of the time that things don't exist, because the way that things are set up make it hard to build stuff that matters. Spend some time over the holidays learning about Pufferlib. Where would you point a mid-unk who is also a noob? Well, do you know how to program? I have guides. So rather than give people the same like poorly worded advice on stream repeatedly, I just wrote a couple really high quality articles. Read both of these. These two. And also Star the Puffer. It helps a lot. More resources to deploy. Yeah, but like first use, what happens when you have 100 engineers and you fail at something and I'm one person and I do it? Like that kind of screws up scaling proposition, right? I'm not using it today, Roger. Today I'm doing CUDAGraph stuff. I have a better project in mind. I have a much better project in mind for Opus that I'm going to do once I have this CUDAGraph stuff done. But this is probably going to be a full day of hell. For context, if I manage to do this, this will kill all of the kernel launch overhead in pufferlib. And this should get us plus 1 to 2 million steps per second. Hey, Will. Okay, so we have, right, the other possibility here. There's one other thing I wanted to test before I got on that. Engel will help us understand financial markets. Yeah, somewhat. We have a few active contracts in finance and commerce right now already. They're sort of small, but already, like, I'd say meaningful. A lot more can be done, though. Heck, if somebody wanted to do, I think the best thing we could do without having any sort of conflict of interest is if we did like an MMO type market. That would be a really cool thing to simulate. Social working. What's that mean? Unity of command. Complete control. Well, I really like open source because like you get self-selecting people who are here because they give a shit. And there is even financial incentive. Like I do hire people out of our contributors. I don't go advertising it because I don't like to incentivize people to do free work by like dangling the carrot that maybe there will be paid work. But it is also true that I do hire people out of the contributors. Like, there are a couple people right now in my that come to mind that I will pull for the next few contracts. There's really no other way to vet people. Like the only proof of can you do good work is are you doing good work? Okay, so this is what I wanted to do. I just wanted to see if the output still maps everything to 0.25. Not organic. That would be so funny if they actually paid everybody. You would think that would leak though, right? I mean, I'm not a conspiracy theorist, right? I would think that that would leak. Ah, look at this. Everything maps to 0.25. You see this? Okay, let's leave that there because that's going to tell us something. State out. Anybody see anything wrong with this, the way this is set up? I think it's got to be in the policy, right? Lots of low quality PRs. I mean, not really, because I just ignore shit that's obviously bad. It's pretty easy to tell, right? It's like people that are hanging around either the Discord a bunch or the stream a bunch and are actually putting the time in to learn stuff and to build environments. Like the stuff I'm doing, if you are already a reasonably experienced programmer, it's actually not that hard to learn. Like you actually have to listen is the thing. But a lot of the stuff I'm doing, well, I'm not going to say it's not hard. It is very simple though. Like I've had multiple people just listen to what I've been telling them, start writing very bad code, and like get to writing very good code within a few environments. That I would believe. That I'd believe. SF parties are so weird. I'm very glad to not be an SF. trying to think what could possibly be causing this to map everything to 0.25. That's so weird, right? Oh wait, so there's a sigmoid. And then there's this gate. No, the gate is this. Sigmoid and a lerp. Does this just crunch everything to 0.25? I don't think so, right? I'm gonna go read the site and come back next stream with some questions. Yeah, it's those guides will link you to pretty much everything. They're meant to be worked through, not just read. Like the programming and ML guide, you can just read. The other one is like a work through this, and it will take you through the process of building some environments. You can do it pretty quickly. Like, I think spending a weekend on your first environment or two is more than enough time. It's if you try to do it in 2 hours with LLMs, you're not going to learn anything. But like a weekend is more than enough time to actually learn quite a bit of stuff. Yeah. Like I say, this stuff is not simple, right? This is the hardest branch of AI to get into. Um, the thing is, I've made it a lot easier, and at least you don't need massive compute resources. But it's still hard. Like, there's a lot of engineering, but I've kind of reduced it to like, if you can write simple low-level code, you can write useful environments. If you can write useful environments, you can start running experiments. If you can start running experiments, you can start testing hypotheses. You can do this very quickly. And I kind of like drip feed you the rest of the papers and things that you'll need to read along the way. It's not that many. Like, if you read 10 total papers over the course of several months, you will be in a very, very good spot. Just pretty much exactly what the guides say. Like, I put a lot of work into those. Yeah. Hey, I hope you enjoy. Welcome aboard. We're always looking for new contributors. Like, most of the environment code at this point is from contributors. Okay. I think, let me try one thing. What if I just do out equals state plus 1? Can I just do this and see? I'm basically just trying to figure out why this is mapping everything to 0.25. Actually, I know for sure this is not expected because the non-graph trace version doesn't do this. More math focused than engineering? Not at all. I started actually having way more respect for math than engineering when I was like 16 or 17. And then it just was repeatedly the case that engineering was more useful to me than math. So I'd say that my toolkit now is 85% engineering, like 10% basic science, 5% stumbling through math. You can watch my PhD defense online, and like you'll see that there's little to no math in that talk. It's not to say that math isn't useful, but for what I was good at and for how I think, I can make a much larger impact with engineering than anything. Okay. Look at this. This gate is somehow messing stuff up, it would seem. Not as good at C and RL as it is CUDAGraphs. That's why I feel disconnected. That just means it's dumb. Like, if you're saying, oh, this is really good at doing like routine basic tasks fast, that's completely useless to me. Because the thing is, I can take any decent programmer and then get them working on this stuff quite quickly. You see what I mean? But that's not what people are claiming, right? People are not claiming, oh, this is really good at doing basic bullshit. People are claiming, oh, this model feels, so smart. I can do 100 times more stuff. The future is like whatever. Like, no, building like stupid standard crap 100x faster is just like meh, right? YouTube recommended your defense on my feed. Yeah, it kind of blew up a little bit, at least for a defense. It was a good talk. I put a lot of work into that. For context, I spent less than a week writing my thesis document. So that 170-page document, that's like all my papers stapled together with an intro, a conclusion, and a few little sections in between. I spent a full 3 weeks preparing my defense, like the talk. Yeah, Martin, but like now it's Carpathy and other people, right? And like, Top Labs people saying this shit. So I think they're full of shit, but I'm going to give it a genuine try. And I'm not going to come back for another couple generations if it's wrong. Running post is really good. Thank you. I'm not a gifted athlete. So stuff like that is quite large of an accomplishment for me. I have a few fitness articles on there. That's the only other content I will allow myself to post once in a while, because it's very, very important to be in shape, and a lot of people in our line of work could afford to do more of that. I've got this awesome, like ridiculous bodybuilding gym, and powerlifting gym in Florida, and I'm gonna be trying to put a little bit of my lean muscle mass that I lost back on in the next couple of months. Oh, wait. Is this supposed to lerp everything? But this doesn't make sense, right? Next context, building pipeline image data loader. Placed a list of tuples with a dictionary. Was the order basic memory copies to be random, regressing per agents need memory. The thing is, they have the whole thing in their context. It's not just like, oh, they're bad when you're out of context. They're bad even when you have a relatively short context. How do you prevent yourself from relying on LLM too much? Well, I don't have a smart LLM. You see this model? The model that's doing my tab complete here is not Cursor or something. This is SuperMaven. It's a really stupid model. It's not capable of writing, it's not capable of solving any problems. It's basically a fuzzy LSP. I really like this model because it frees me to think faster, because I don't have to focus on typing so much. If I typed 160 WPM and if it were effortless to me, I wouldn't use this model, right? But like this is super nice. It saves typing, not thinking. So it's not like I don't use literally anything. Why don't I use a better model? Well, I don't want to rely on something to think for me. I don't want something that thinks for me. And two, it's fast. You see how fast that is? As soon as I hit enter, it's already there. I don't want the latency. I don't want anything that interrupts me when I'm thinking about stuff. The thing is, this goes through a linear layer, right? I don't really put too much stock in the flow state thing. Because, that's supposed to be when something is not too easy or not too hard. It's just as important when something is really hard that you're not interrupted, right? Or really easy that you can do it faster. I actually do think that there are forms of the current LLMs that like I would find useful, but it looks very, very different from the way that people are using them now, and it's not worth it to me to even bother like trying to set that stuff up. Hey Boris, how's it going? I'm sure you're not calling me old while you know, being absolutely mogged. If you're gonna come here and like post older, bro, you better post like powerlifting total by the way or something. Otherwise, Uncle got hands. More because you want to learn something. Writing what you're expecting. What projects you want to work on. Well, I mean, the stuff I'm writing is important, right? It's very important to like understand each chunk of this. So this puffer thing I'm working on is essentially an effort to um, this is going to reinvent the field of reinforcement learning. In fact, it already has. Like in 2 years, I've made RL 1,000 times faster. This update is going to make it about another 2x to 3x faster, and then in important cases, it'll be like 10x faster yet again. And those are not made up numbers. Like you can actually check it, and that is legitimately what it is. So I like to work on stuff where if I don't build it, nobody else will build it. It has a huge potential for impact on science and tech in general. For the last long amount of time, it's been RL. Probably once I have RL in a good spot from this, which is actually going to be within the next couple of years, I'll probably start going and looking for areas of science that are highly dependent on simulation and seeing what we can do now with reinforcement learning for those fields of science, as well as for some other like commercially valuable problems. The profit is not the first objective with what I do, but it is the second objective. What if I just set this to output? Or can I just do hidden? What if I just do this? So yeah, Mira, for context, so Puffer is kind of like a private lab. All the stuff you see me working on here, it's open source. We've got demos on puffer.ai. All our code's open source. But then we also build high performance simulations for companies. That's the business side. There's a few other things, but that's the main one at the moment. Simulation hypothesis, don't care, nerd snipe. Okay, this is interesting. Only be about RL? No, not at all. Yeah, not at all. Generative is very important as well. But like RL is very cool in the sense that like the types of problems you solve with small RL models are the types of problems you just don't solve any other way. You get superhuman control instantly. Why not go after those fields now rather than wait? Because it'll be dramatically easier with the RL, like the next gen of the tools that I'm building. We are actually we are going after a few other fields right now on the business side that are easier to do with the tools that we have now. And essentially just harder problems get easier every generation of Puffer. Like there's stuff that we're doing now professionally with 3.0 that would have been virtually impossible with Puffer 2.0. And the same will happen with 4, and I believe the same will happen with 5. We already have plans for that. Okay, so this is producing like a unique output. Can it not trace my custom kernels? I'm so confused. Best way to contribute just a new end? Well, if you're new and don't have RL experience, it's the best way to get started, right? I wouldn't necessarily say just build an env if you're already an experienced system developer who has a ton of RL experience. But if you just like have some programming background and maybe know some AI, like that's generally the most accessible way to get started. And there are people who have stuck around, right, built several envs, like really gotten a feel for this stuff, read some papers, and who are now contributing to our research side. Right? There's this sort of ladder of accessibility. What does this mean? You know what I want to try? What if I try this? So we don't use the kernel. Does this also give us the 0.25 degen solution? That would be really weird, right? Oh, what? Um, guys, that is. This is what I say when there's just like cursed undocumented errors. I'm sure this wouldn't happen with just native CUDAGraphs either. This is like Torch doing some weird stuff with its tracing. Low-level code for loading to network stacks, containerization, and know nothing about AI ML. Well, I have good news for you. It's harder to teach people the system stuff than it is to teach people the AI stuff. If you take a look on my articles tab on X, I have my guide to programming in ML. The ML stuff has just decent advice for reading papers and stuff. But what you're going to want is the RL guide. It actually has like a step-by-step walkthrough. And if you have a systems background, it'll actually be very, very easy. Like making a new env will be, I can make a new env in an hour, like a basic env. So it's definitely the type of thing that if you have more experience to, and you can work through in like a cozy evening, and then you can do something more substantial in like a day or two, maybe a weekend. Like a lot of RL right now is just bottlenecked by AI people not knowing systems, frankly. I only started doing all this system stuff 2 years ago. I wrote Python for 10 years. And now, 2 years later, we have the majority of the project written in C. For Puffer 4, we're doing kernels, we're doing all sorts of stuff. Oh, that's so weird. Okay, so I found the problem, guys. Look at this. These two things are tested to be identical, okay? But for whatever reason, this one here, this is not getting traced somehow. I don't know how that's possible. Let me see if I can. Low level code, yeah. Start with a guide. Cool. Okay. Prompt engineer? Not at all, man. What did I tell you? I use them for fuzzy docs. If there were a doc page from Torch on like CUDAGraphing requirements, I would just be reading that instead, right? There isn't one. Yep, that's the right one, Rushi. And it's much more of like a work through it type of a guide than it is anything. You can read it once first if you'd like, but it's kind of structured like, build this, read this other thing, do this. The idea is by the time you finish going through that guide, you are like a very qualified, you are very qualified in RL. But the first few sections of it will have you build some sort of non-trivial end. Like if you can build a simple arcade game, basically, that's high perf and get an agent training on it quickly, that's kind of the entry level for contributing. If you can do that, you can already do useful work though. And that's on the order of a few hundred lines of code tops. We do like our C around here. It's very simple C. Python based language, we can do basic CAD. Doesn't Yassine have that? I don't know. Nicholas, you're asking me stuff way out of my area. Try it and see if it works. Learn by doing. I'd say 80% learn by doing and 20%, the other 20% you actually have to do. Like, you still have to read some material, but most of your time should be spent building stuff. Are you going to integrate Puff with Unreal? Not unless a client really wants me to, because, like, it's so slow, right? You'd have to run like 1,000 distributed instances of Unreal to get a reasonable amount of data. Our environments run like 10,000x real time. They're super fast. Do you have to explicitly set the stream? The CUDA call. Well, yes and no. So you can still train stuff at over 100,000 steps per second on CPU. When you're doing experiments, it's going to be much more helpful to have a GPU of some variety. You can rent a suitable GPU though on Vast for like, here, watch this. These aren't great because like sometimes they downclock them and stuff, but like here, this is 13 cents an hour, this is 30 cents an hour. So if you want to be able to train stuff, you don't actually need a lot of compute, right? You don't need H100s, you don't need H200s. It will be helpful for you to have access to some GPU, but you'll be able to dev for sure on CPU. You'll be able to test basic stuff on CPU. It will be nice to have a GPU when you're training stuff. Oh, we actually, repeat contributors get access to our hardware as well. We have a small cluster. Open code plus op is pretty useful for tasks, where things are. Giant code bases. Yeah, but that's like, I just don't have a code base like that, right? Like, yes, LLMs are good at like helping you make sense of nonsense. In my mind, I work very, very hard to avoid producing nonsense in the first place. I'm gonna try this just to see. I'd be surprised if this is actually the case. Do you actually need? Hang on. After my PhD, man, last couple years. That's what I'm saying. This is like completely doable, right? Is this really just gonna put it on some random stream? Oh, right, because the torch stream is not the current CUDA stream. Diffusion or transformer? I think they're different. I don't know enough about diffusion models, frankly. You know we don't use either of those in Puffer, right? Like, it's a very different application. Pick up a textbook. No, I had very basic systems intro for my undergrad 10 years ago, right? So like I know what memory allocation is, I know what a pointer is, right? I know what is a stack and a heap. And then I just started writing some C. That's pretty much it. And I wrote very simple C. And then it turned out, right, that I could write about the same amount of C as the code I had in Python, sometimes less. And it was very simple code, and things are 1,000 times faster. That was the major discovery for all of this sim stuff. Isn't that funny? That was the major discovery. I'm not even joking. Really? Wait, is this correct? Did am I seeing this correctly? If so, this is incredibly stupid. Are you serious? You gotta be joking, right? Is that documented literally anywhere? Of course it's not documented. They expect you to be a complete and utter monkey and not write your own kernels ever. And not manage any streams. So they just don't bother documenting this crucial thing. Great. Well, good job to Grok for that, given that it's just not documented. This is actually, unfortunately, one of the things that I think we're going to have to use LLMs for, is because LLMs exist, devs just don't feel like they need to document stuff anymore. And there's literally no way to figure this out, probably, other than having read just all of the code out there. That's insane. See, I think the type of thing that I would really use often, if I could just stick this pufferfish that I have here up in the corner and say like, hey puffer, what's wrong with this? Like, why is this one working but this one isn't? And it would go figure stuff like that out, just like having it be an encyclopedia of niche technical stuff rather than trying to have it do things for me. That would be awesome. Why do some messages not make it? Because there's a default filtering if you either type too fast or put links or whatever. I don't control that. It's just whatever the platform does. Template functions, I pass the function. Dispatch helper. Made if you have. Yeah, so Eric, I did this intentionally because do you have a way that does this that doesn't have macros and stuff? Because the way Torch does it, it does everything with macros that eat all your error messages, which is terrible. So this at least preserves error messages, and I actually don't think we need to support too many D types. I think it's probably going to be 1 or 2 D types, and depending, it might just be 1 D type, and then there won't even have to be any templating, which would be ideal. Retrieval augmented generation. Yeah, I guess the best form of this, Jess, would be, it could be more than that, right? If you wanted something super fancy, it would be you'd have something that has an environment that would go pick snippets out, tell you, I found this snippet of the code here, actually be able to point to it, write a test example, and then isolate a bug. That would be great, because then you're not handing over control to your repository, right? You're basically just having it like search out these niche technical things, because I think I spend half my time on average getting stuck on these things, at least for projects like this, where I have to deal with CUDAGraphs, I have to deal with it through Torch, it's not documented, the error messages are basically non-existent, right? Is getting the current stream slow, I wonder? Dispatch. Header file. Well, this is, wait, is this not what we're doing? This is, I have this right here, Eric, right? This one is like that. Some of this is test code, right? So this is This is not intended to be example of high quality code. This is me messing around with stuff, figuring out the way to do stuff to reasonable qual standards. Like, this is actually the first time I've had to write these type of kernels for like learnable operations. The only other kernel I've had to write before this update was the advantage kernel, and that's not like that doesn't have to hook in the exact same way because it's not actually going to have to be a learnable op. That's like so cursed though. Okay, let's see. Let's see. Okay. The question is, can we train now, right? And I do post these silly articles occasionally. Raysom's awesome. Ray is also like not super big on AI code, and Ray is probably one of the devs I respect the most. Like Raylib is just genuinely, it's such a good example of just a thing that has been developed correctly, and the quality of the development of that project and all the effort has put in is what makes it such a useful toolkit. Raylib is just awesome. Okay, so why are we seeing 0 score here? Lovely. I do some other weird stuff. Oh, am I still adding 1? Yeah, no wonder. That'll break it. Left my test code in there. That was brutal though. So far we had, having to reset the stream back to default as major bug. We had existence of other streams starting during tracing as major bug. And then we've had streams starting on other, what is it? Yeah, kernel launching on wrong stream. Okay, so this produces at least some learning signal. There's a whole bunch of numerical checks because like we're doing some jank stuff at the moment, but as soon as I see non-trivial learning, like this is good enough for perf tests. So simple does not mean easy. Yeah, simple does not mean easy. Like by the time this is done, the product of this is going to be so simple that anybody who reads this and who has not watched these streams is going to like just assume I'm an idiot for spending months on a relatively small chunk of code that looks pretty simple. But like, you see why this takes forever, right? Like, you see the types of problems I run into. Because nobody expects you to do this, right? Nobody expects you to go CUDAGraph trace the torch, your TorchNet in C++. Okay, we have vec receive in here. Is this already with 8 threads? It is. Okay, nice. So can we run profile on this? Because that just got us over 7 million steps per second, even with profile on for chunks of it. I'm trying to make sure we get all the bugs. Okay, here's our profile. We still have a ton of synchronizes. Oh yeah, I added these in. Obviously, we still have these. Cool, I can fix that. Still quite a bit of kernel launch overhead. CUDAGraph launch. I have to look if these are now, like, do these ops not include... Well, A10 mapmol is still in here. The CUDA time, though, is low. I don't know if this is now getting included. That's not super useful yet. Let's just let's cut out these extra synchronizes. Like, we don't need all these synchronizes, right? And then let's see what this does for us. There's some copies we can still optimize in here that'll get us maybe a couple 100,000 SPS. But I think from here, then majority, it's the rest of the tracing. Is this profile? Yeah, this is a good profile. Hang on, we didn't want this. I wanted to run train first. $7.4 mil. Pretty good. And I want to see the number of kernel launches or synchronizes. I don't see how they would. Oh, I'm also gonna check a couple messages because I am responsible for some flights today. It's good. I don't know why I scroll this, it's just gross. Alright, so here's what we have. Perfect. You see this? We just got rid of most of these synchronized calls. So we have CUDA stream query. I'd actually like to know what this is. The kernel launches, I believe, is now substantially lower, but we still have a lot of them. You see there are 32,000 kernels here. But 32,000 kernels should be... Let me go see what the output of this is. They still appear. Kernels will still execute. Oh, cool. All right, so next we can let's commit this first. And I think it's going to be pretty easy to trace the backward, right? And actually, I'd like to go grab myself another quick cup of tea before I start the next segment, because we fixed the evil bug. Took about, what, that was an hour and a half? Yeah, I've been live just under an hour and a half. That wasn't that bad. And now what we're going to do, once I get my T, we are going to uh, apply a graph trace to the backward pass. And then I think ideally we're going to have to trace the network update step. Like I think we have to trace the optimizer step. I don't think that's a problem. I actually think that's pretty straightforward to do. We shall see. And then we'll see what happens with the profile. My hope, I think, if we can get to 8 million steps per second off of CUDAGraph optimizations, that's pretty nice, because then I just have to find an extra 25% overhead somewhere, and we'll be at the 10 mil target. I'll be right back. Yep. Okay. That took a while to boil. Yep. Hey, Jess. Test CNNs. Welcome. Okay. Next segment. We are going to do backward pass. Or not backward pass, backward, forward, backward, whatever. The training section. So what we need to do, what we need to do, stream meeting messages, fun. I can't do anything about that. Do you graph the backwards? Actually, this is something I can use the docs for, right? Let me think. So this should be torch CUDAGraphs. I just want to see if they graph the dot backwards. Actually, I can just look lean RL and see what they do. Where's the graph in it? Okay. Okay, so rollout has it here. Is this not graphed? Actually, here, let's do it this way. Where we celebrate is banned from stream. What? Does YouTube block you from saying Merry Christmas? Are you kidding me? I don't have that set up. I think it's just eating random messages. Okay, put it in a sentence and see if it blocks it. That would be insane. There you go. See? Okay, it's just it being weird. I was gonna say. That would make me mad. Yeah, all right. Welcome, Elliot. Okay, we're gonna start with the forward pass of this then. Check Discord. Hang on. Yeah, that's weird. I don't know. I mean, it's not blocking it for everyone, so I assume it's just the stream being janky. What do you want me to do? Look, if anybody has a better alternative to restream, or like whatever that doesn't eat messages, let me know. But if it's getting eaten on YouTube, like if you're not even seeing it in the YouTube chat, wait, are you seeing it in the YouTube chat? Hang on. Let me see if it's... Oh, yeah, you're just posting a bunch of messages. Yeah, so Restream is eating them. If anybody has something better than Restream, I will gladly use it, but meh. I think it's just discriminating based on the number of messages you send, frankly. I'm pretty sure that's all it is. Alright, back to real work. So this is rollout graph. So this will be forward. I think we can actually do... Can we pass a function? Yeah, we totally can. What's the C++ syntax for that? C++ syntax, pass no arg function. Okay. Just a void star? I mean, that's fine. We do it the C way. I'm happy to do it the C way. But pufferl pointer. Oh, it does have to take one arg. I think it's like this, right? If like physics, can I work? If I like physics, can I work on this kind of project? Yeah, there's plenty of physics. I mean, we typically start with lo-fi. We're not low dimensional physics, not low fidelity. But like here, this is physics-based, right? This is a drone environment. We actually have some swarm environments. We've got driving. This is arguably a very simplified physics model, but technically there is one. Here, this has a dodgy physics model. I mean, technically anything is physics, right? Like any of these things are physics. It's just the fidelity and like the thing that you apply it to. Boop, boop. Drone's probably the best example. Not in college yet. And final years of high school. We'll learn, right? Like, my guides are pretty accessible. Honestly, the hardest thing is just getting the core programming background. I think I told you this yesterday, unless it was somebody else. You are going to eventually need to get like basic linear algebra and multivariable calculus, at least derivative calculus. The ideas are quite simple. The manual calculation of derivatives is not super applicable. You do need to know the idea, the concept, and like a few of the things about this. Honestly, the end stuff is the hard frac. The end stuff is the hard part. Very few people can just write good, simple, fast code. And writing good, simple, fast code lets you do basically anything that you want. And the problem is like there are hard and fast rules for a lot of it, but a lot of like some other pieces you can't get hard and fast rules for. Like it's pretty objective, but it's also pretty hard to quantify, if that makes sense. I will tell you, I think that probably high school was the hardest chunk of my life. Um, I will never work that hard again. So things do get easier and things do get more interesting. You know, as you develop more skills, you are able to work on things that are more interesting and more directly useful. At 15, I was like trying to figure out how to knock together neural networks in god awful MATLAB or like Python with NumPy. It was just such a mess. Oops. Graph. Mostly in quant. C at 11. I will be shocked if you learn to write decent C at 11. I would be genuinely shocked. Okay, so this still runs. So now we actually have, you see this? We actually have a relatively simple way to do this. Let's do this like replay, Pufferella replay forward. I think I can just do this, right? I mean, this will end up being quite easy then, because we can basically run the same code with or without graph trace on, without having to really make any big sacrifices. Yeah, that still works. Look at that. 1.4 mil. Alright, forward. This just dies. Go away. And cool. Where my graphs? Where my graphs at? Right here. Okay, so this is going to be train eval graph. What's a train eval graph? Train forward graph. Train forward call. Okay, so we're going to copy this function. It's going to have to be basically the same thing, right? And then this is going to be train forward call. And the actual logic that we need, for this is, there's quite a bit that we could technically graph. Does an index select trigger a kernel call? It has to, right? Do I need to learn C++ to get ready? I wouldn't recommend it. C++ is really a terrible language. I'm only using it right now because I have to, because Torch is written in a combination of C++ and Python, and I'm using the C++ interface. I need a low-level one. I would be a much, much happier man right now if Torch were just written purely in C. C++, the reason it's a bad language, it's just a whole bunch of stuff, like just bolted hodgepodge onto C. And it's just a very large language as well. There are a million ways to do everything. Code size tends to blow up a lot, and it's actually kind of opaque what things you're doing are slow or fast. So it's actually very easy to end up writing slow C++, which then defeats the point of even writing low-level code. My stack at the moment, I am happy when I get to write Python and C. Actually, less so happy about the Python. Python's okay only when I'm doing stuff that really isn't performance critical in any way, shape, or form. I'm happiest when I get to write pure C. There are really only a few things that I just, are really clunky to do in C. There are a few things like string processing is kind of a mess. I don't know, it's just what I like. Things are very simple, very easy, and very fast. Jai, yeah. Group projects. Yeah, that's pretty much what you do is, right, you come up with a simple project, you pick a new language to do it with, that's fine. The thing is, you should not be hopping languages constantly. This is in my guide as well. Like, there are very diminishing returns on just picking up a dozen languages. It teaches you a little bit about the design, I suppose, but like, you kind of have to be doing a medium-sized project and capable of doing that before you're actually going to really see whether the language is good or bad or what the strengths or weaknesses are. Like it was really only a couple of years ago that I fully began to appreciate the degree to which a specific language can, at the language level, force you to write code in a particular way. It's something that's easy to say, but it's like kind of difficult to internalize. Hopefully that makes some sense. Fundamentals and syntax first. Yeah, but that stuff is very easy. Like most of the time when people have trouble with syntax, sometimes languages just have really stupid syntax, but most of the time it's because the syntax maps to a concept that they don't understand. Though in the case of languages like C++, sometimes it maps to a concept that you don't need to understand because it arguably should not exist, right? A lot of languages have stuff like this. C flavor. Yeah, Eric, the things that C++ gives you, I'm not even really like there's nothing that I have here from C++ that I wouldn't be super happy to just give up in place of C, you know? Like basically the only thing that's kind of nice that you give up is being able to call functions from like thing dot whatever instead of function of thing comma args. I mean, the things that I would actually consider maybe wanting, stuff like named arguments maybe would be nice. There's a lot of compiler level stuff that I would like to be different, like things that should be errors versus things that shouldn't, things that should be default warnings versus things that shouldn't. But C is a very strong base. The macro system kind of sucks, right? But C is like a very strong base. There are very few things that just truly bother me about the language. Function overloading C, I don't want that one. I don't need that. Honestly, it's kind of cool how Raylib handles it. Like Raylib, there's like a base function, and then there's an extended version, and there's like a pro version. They have a few different ones that basically cover all your use cases, and they're just very easy to stick in the docs, one line each. Let me think. Would that even make sense in C if you did optional args? I guess I'll say I could see it, right? I could see it being okay. Yeah, I could see that not being a bad addition to the language, but I really don't miss it, if that makes sense. Because actually, there is a way to do that, right? You just pass a struct, and then you just don't fill out the fields. And that's like decent. Anyways. Okay, so we have trade and forward call. This needs, yes, right. So we need to do graph train logits, graph train new values. Yeah, so we'll do this one. Full rank questions and full on projects. The thing is, there's very little syntax that you should need to learn in order to do stuff, right? Like, because if you look at the way that I write, like if you're used to writing C, right? You're used to doing a lot with very few tools. So if you're used to using very few tools, there's very little that you need to learn about a new language before you can be effective. You'll hit some rough edges, like for instance, if you try to write fully procedural code in Python, you'll kind of see why it's a bit of a pain. Hey Aaron, welcome. How's it going? So we have this one. Mini batch. That's not what initial state does. How many hours? Not including Sunday. It depends. It varies dramatically, man. Like, I can't even give you a good range because it's anywhere from 30 to 90. I would say a good week of work for me is like 60 solid hours. I can get a lot done with 60 focused hours. 70 is better. 70 is tough. It's not a crazy number of hours though. Like I've done way, way, way more hours before. The bottleneck is mostly the clarity and the focus. And like not wasting time on dumb shit. 70 is a lot. Eh. I don't know. I grew up doing 110 for school, so, and then like 90 for college. Which is funny because now, the 70 feels very hard. To do 70 hours of focused work on something like this feels very different from like 70 hours where you can kind of turn your brain off half the time. 12 a day? Well, I mean, 12 times 6, right? There you go. I'm going to be trying something slightly different actually while I'm in Florida, which is I'm going to try to have more days that are fully devoted to work, and then I'm going to have some days that are more split. So like I do a short block, maybe 3 to 4 hours in the morning, and then I go to the gym for at least 2 hours. I'll probably be out for 3 hours in the middle of the day between gym and lunch, and then I come back for another 3 to 4 hours. So I'm going to try that instead for a little bit and see if I like that more. Florida beaches. Beaches aren't really fun for me. Rest hours. Yeah, that's what I do. I'm pretty fresh now, though. I just got back from vacation. All right, so we have this, we have this. This one's supposed to be we have horizon. Okay, I do. Okay, so we got this. Logic, graph train, value. This looks good. Well, Aaron, we have already, we have some commercial impact already. Like we've got a few clients now. I think 4.0 should put us to the point where like anybody can just run this stuff on their laptops. This should really, really lower the compute barrier to entry. I think that we'll have it by 4.0 or slightly after. We'll have it to the point where the arcade level tasks pretty much are full automated. Like you can solve anything that looks like of that complexity pretty much automatically. I think within the next year after that, we'll get to solving the medium level tasks pretty much automatically. You know, basically the environments right now that qualify you to be a professional contributor, right? Like to work on contracts, so actually commercially valuable stuff. We'll start to have that level of stuff fully automated, solving it, not building the sim, obviously. And then we'll be able to like, you know, use our tools not fully automated, but with high confidence to take on some very hard problems. So the timelines are only like a year or two max out now. It really, a lot of it just depends on how much focused work I can get out of myself and what other roadblocks we run into. Like this stuff is hard. You see the type of things I have to fight here. Low dim robotics, Melanie, right now. Low dimensional robotics. So like drones are considered low dim robotics. Not a ton of degrees of freedom. You don't need a super heavy sim. There are a number of areas of robotics that we could go into productively right now, and it's mostly just a matter of clients, right? So we don't really tend to go try to like build a fancy sim for 3 months and then go sell it. Like the professional side is much more, we build all these tools and then people come to us for general RL and then we build sims based on that. Coffee cup, this is the Florida mug, is big. I'm on a tea kick for the time being though. Had too much damn caffeine lately. All right, let me get a bit of this stuff done. So yeah, so this one here, this needs to be graph train MB obs. Like this. Right? And then what we can do is offer a graph train logits. Graph flatten false. I think this is good. And then state matter? I don't think state matters. I think we're good. Okay, so this is our train forward call. Right, train forward call. So now what we can do is we can put this, we can just do train forward call on buffer. And then we just do logits. I don't think these modify in place. I think this is totally fine. So this is not traced yet. Just gonna make sure we haven't broken it. Training forward. Oh yeah, because this has to get defined way higher up, right? Is this it? Forward call. Yeah, we'll do it like this. We get train forward call. Any other dumb omissions? Very good. Then hopefully this is just easily traceable. Do not convert 13, 7% buffer. Match. Get our stack traces. Oops. Let's break. Capture graph, really? Well, let's not do the capture then. Let's do this first. Something batch. I'm not using batch anywhere. Just check on one thing. Compile train, okay, cool. So we have an execution error. Make sure we're good there. I have I'm trying to help somebody with a catch a flight, and the weather is not cooperating. Not an app user, nope. Actually, this is probably the last day I'll have this. This was a temporary $100 phone. So it's kind of funny, if you look at this, the 3 cameras on this thing. This is what you get for a $100 phone these days. You'll see the new phone I'm getting. kind of bought something silly. All right, where's this? 1379. That's just the train call. The easiest way to do this is to just like there we go. Yeah, tail scale. I have it set up so that when I SSH in, it just boots me right into a container as well. It's not like SSH to the container. It's just that the setup script does it. It's all pretty light. Okay, so these look like the correct sizes to me, right? Wait, 5, 12, 1, 128. This is the correct. Huh? So what'd I mess up? Oh, the copy probably, right? I bet you it's the copy. New value sizes. Oh, I know what it is. I bet you it's this. Does that make any sense though? Let's try this. Do this. Oops, not that one. Dummy. Oops. Okay. It was probably just this, right? See if that works. Oop, what'd it do? And forward ball. We also have to do bufferel. You gotta do both of these. And that should work. It's basically the same same thing. You have to trace the net twice though, if you have different shapes. So the idea is you always have the same shape at train and the same shape at rollout. Trace it twice. Kind of backward through a graph the second time. Oh, you know why? I know what this is. I think that this will work if I put this here. I think. Because I can do... Yeah, if I put this here, I think this works. And this will take another bite out of the CUDA launch overhead, hopefully. Eh? Wait, we're not even tracing this yet, though, right? Yeah, we're not even tracing this. So, because this is train forward call, logit's new values. Oh, yeah, this, what? No, this copy underscore. Does copy underscore not preserve Brad's? Oh, I guess it doesn't. Right? How do you do that then? Probably. Blah, 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 blah. Fully preserved gradients. Interesting. That seems weird, right? Okay, so if this does preserve, did I miss a kernel maybe? I guess with training there's, what's the diffuse scan kernel? Oh, you dummy, you forgot this. How did I forget both of these? Well, that'll do it. Where's it? Yeah, this one. Launch, used, scan forward. So this is the same bug from before. We already fixed this. It's launching on a different stream, so it's not capturing gradients correctly, is my guess. I took it, was Carpathy? I don't know if Carpathy was still, it was Justin, I believe, was teaching it. Justin's lectures are very good. He gets a lot of subtle things correct that like most would just skim over. Okay, now I'm confused. I just fixed the kernels. Launch, fused. Yeah. Just getting the current stream, right? To the launch. Are there any other kernels? I think so. So what we're calling train forward. You're copying the obs and state in. And then you're getting train logic to train new value. But then these get copied, train logic, train new. Yeah, these get copied in. And this is supposed to preserve gradients as well. So this op definitely has gradients. Where's the graph break? It'd be really nice if we could figure out where. Do both of them by mistake? MB state is here. MB obs is here. These get copied in. Train forward. It's not even tracing yet. Logic's new value. This should be fine. This should be fine. I want to see if I just do it this way real quick. I think it's this, right? No, it's tuple. It's tuple. Okay. Well. People are saying that this actually is supposed to work. Here's the restroom real quick. I'll be back in a minute. Checking one thing. So, normal tensors. Do I have to mark these as requires grad? Because this one, let me try something. We do like this, okay? And then I'm going to restore this signature like this. And then the only difference do not do that requires gradient. On. It's actually these ones, right? So it should be like this. So I'm going to see if marking the outputs as requiring gradients gets the copy correct. Presumably that was what's happening. Torch is very implicit sometimes. It's kind of annoying. A variable that requires grad is being used in an in-place operation. There's got to be a way to do this, right? This should be standard. Let me mess this up. Don't mix that. Um, I don't know how much has changed. Probably the newer versions have transformers and stuff. I mean, ML fundamentals are really like autograd, supervised learning, train loops. Like it's what's a con, what's a matmul, what are like various things. It's a lot of it is very much the same. I think the hardest part is just developing sufficient engineering maturity. Yeah, seen latest vid. Oh yeah, yeah, the interview. That was fun. Don't set requires. Yeah, this doesn't work either though. No. Snake style CNN. Oh wait, this is just, hang on. Got any suggestions? Most used ResNet. Snake style CNN. So Jess, a few things. You're probably, if you're doing one hot embeddings right now, can that just be flat? It's like a couple thousand, isn't it, if it's flat? So try a flat net for comparison. Um, you can try like a couple deeper stacks. CNNs get slow very quickly though. I mean, in my mind, the goal is going to be going forward that we spend less effort scaling the encoders, right? Like the encoder should just, the goal of that should just be to get it into some reasonable hidden dim. They don't actually have to be powerful. And then most of the work is going to come from the main network because we actually have an architecture that stacks nicely. And Justin, what I'm going to do, I think, unless I come up with something better, I'm going to give it the best possible chance of working. So I'm going to have an environment in mind that I think I could write in a few days that will be roughly 1,000 lines of code. So standalone, doesn't depend on anything, very simple interface to interact with other stuff, but like doesn't have to use anything else directly. Only uses one very common dependency, nothing else. Tons of example code. So like really, really good case for Opus, right? And I think it's gonna just fail catastrophically. We will see. Takeaways from TinyGrad. I like what I see so far. So I think I need to do more looking into it. I think that there's going to be a way that I can use their kernel gen. I'm taking a break from that now because I have some other optimizations independent from kernels for Puffer that I need to get done first. I wish it were not written in pure Python. You know, I think TinyGrad in C would be awesome. Right now, it doesn't give me enough low-level control, and it really seems like they kind of expect nobody to want to manually write kernels or like manually interface at that level. And like that would be okay if they magically had crazy high performance, right? But the thing is, most of the time they're like matching Torch's eager mode when you turn on all their compilation options. Sometimes they're faster, sometimes they're slower. So like it seems to me that we still need lower level interfaces. That has not been disproven. It seems unlikely to be disproven. And I think it's way better than JAX at least. Like if you're going to have a pure Python library, TinyGrad is very good for that. They will continue to get more performance optimizations over time to be more competitive with Torch and other things. It's a much smaller project with a lot less jank, which is nice, but I really would like more lower level interfaces. And then there are just a few missing things as well. A few missing things. I am going to spend more time with it. I told George I'd spend more time with it, but I need to finish some of this stuff first. Like also their source code is very nice and succinct. I kind of view the golfing they do as just a quirky style thing. You know, like their code isn't bad in the sense that I can literally take the same code and just add some white space and it's fine. Or like, you know, put the double nested loops or whatever compressions into two lines, like basic stuff like that. But the actual, so what I've seen so far, the actual control flow is fine. The style's just kind of quirky. And try one other thing. This is like some weird graph shenanigans. ArcGI. Very little. It's like, it's kind of interactive, but the interaction portion of the problem is trivial. So it's like, it's still mostly pattern recognition and then a tiny bit of interactivity. It's like the inverse of what I do. Good job giving me completely wrong answers, Brock. See, this is what I mean by I say like these models are just terrible. Like this is just bad. Actually, let me try it. I might actually be wrong here. Let me check real quick. I don't think so. I might be wrong here. Let me double check. I don't see how that would work though. Cause like, what's it do? Forward, train. Yeah, I already said I'm gonna do a stream with Opus. I'm not gonna interrupt my work now to go fuck with other models. Especially when it's literally just the labs leapfrogging each other every couple months, and I've had people telling me this every couple months for the last year. Like 2 years even. The only reason I'm even doing this is because Carpathy tweeted it. This is what it told me to do, right? Yeah, like this exact thing. Yeah, exactly. See, it's stupid. I tell you, it's stupid. That's like a basic, that is a super basic thing. That's like a 4-line bug. I gave it full context, and it's just wrong. And I'm supposed to expect that these models are superhuman. Like, they're crap. Right? Okay, so here we have this. This works now. Now can we trace the graph? So we can do bufferl dot train forward graph, play. Too far off the manifold. But like the thing is, the stuff it knows is usually stuff I also know. If the things can't generate anything new, then what the fuck am I using them for, right? That's not even something new, though. That's like literally, I mean, that's just a hard fail, is what that is. That's just like fundamentally not understanding what a graph is. Yeah, exactly, Jess. It seems architectural to me at this point, you know? Like by 3.5, it was kind of like, okay, what's going to be emergent versus what isn't? And now, several generations later, we have way better models, but we have a lot of the same failure modalities that we had 2 years ago or three, whatever it was. Not that long in time, but it's a lot in terms of money poured in. And it doesn't seem like they're getting qualitatively different. Like they're doing more of the same, but better. Yeah. Ilya's very good. I watched his interview on stream. His interview is very good. Did I post that as a video? I should have if I didn't. Well, 4 run-of-the-mill stuff doesn't cut it though. But it's like, people, oh, you're so behind if you're not using the latest agentic, whatever the fuck. It's like, oh, but it only works for run-of-the-mill stuff when it fails. Well, like, so you're behind because you're not using the model that does run-of-the-mill stuff because you're assuming that you're just doing, like, huh? Right? Good engineers are not going to be doing the run-of-the-mill stuff most of the time anyways, and they're pretty darn quick at it when they are. Like, when I'm doing basic stuff, I dev pretty fast. Hello. Welcome. So, like, what's the point? I mean, the thing that I would like, which should be possible and, like, kind of works, but is generally pretty bad, and is not at all validated, and is hallucinated more than half the time, is, like, these things have read just about every public piece of code. So, things that are not in the docs, that are, like, niche bugs that somebody has written a comment for in their repository above, like, the one line that's very hard to find on Google, like, that's stuff that would be valuable, right? Because that's where I waste half my time. And that's honestly the thing that, like, burns me out a ton, is just having to waste time and effort, like, tracking stupid bugs, because it's so boring and so obnoxious. This does it. File replacement over multiple lines. You can do that with, like, not AI, though. You don't need AI for that. Why did I do self? Yeah, sure. But, like, that is not... That's, like, a very marginal thing, you see? Like, I don't spend most of my time doing that. That's a super marginal thing. So I didn't attend NeurIPS. I ended up being there for one evening, and I went to one dinner because I randomly I had a layover on the way to Hawaii. So there might be a picture or two of me, but I didn't actually go to the conference. Okay, so what is wrong with this then? It's much faster. I think we have to do zero grad as well, right? Where's the optimizer? Yeah, move on. Mentioned you were there. Yeah, so that's why. Um, and I wasn't actually even going to go to anything. The reason I don't go to the big conference is because I got pneumonia there last year and it nearly killed me. So I kind of just said screw that this year. Um, I got the only reason I even went to a dinner is because I went to check in at the hotel. It just happened to be the same hotel as the conference hotel because it was the nearest good hotel to the airport. And I happened to run into my main collaborator like just immediately on getting the registration. It was like a small world kind of a thing. How much did you spend on your warehouse? I'll tell you the gym equipment wasn't bad. I'll tell you the PCs were, what is it? It's like 10 desktops, I think, plus two tiny boxes. Two tiny boxes. It's probably between 80 and 110,000. The heck is wrong with this? Man. Savings or contribute? I mean, I initially was buying stuff off of savings, but like, Puffer has more than paid for them by now. So, like, the initial ones were bought off of like the initial money that I put into the company, and then we started making money, and now we're buying new machines off of profits. Are you working on any new papers though? I work on releases and blog posts. I don't really do papers. I don't really publish anymore. It's not worth my time. I don't get that much out of publishing. The peer review process is an actual joke at this point, and I actually get more exposure in less time out of just writing a good blog post on my release than I do from a actual published paper, and without a 6 to 8 month lag time for review as well. So I don't know. Maybe once in a while I'll submit something if it's easy, but there's really not much reason for me to be writing papers anymore. Favorite puffer env I've worked on. Ooh. Let me see. I have to look at completed M's that I've personally worked on. I mean, I assume that you don't count just like adding a little binding for, because Slime Volley was cool. I guess like Snake was the first one, but it's kind of dated. I don't know. I think neural MMO is just far and away the best one. I mean, I've made smaller contributions to a lot of these. Probably that doesn't count. This one is surprisingly fun. Like these types of M's, they're just like this. This is super simple and easy, and you can scale it up very nicely. This is basically a scaled version of that with some extras. This is kind of cool, right? Yeah, a few M's. Okay, why is this broken? Why is this broken? Capture graph supposed to work. Torch should have an example of this. Is there like a more recent one? Yeah, see, this isn't what we need either. See, they're capturing here. They're capturing the entire thing. Is that better? Thinker professional. What makes a useful env? Do 231N. I mean, it's mainly clients come to us asking for things, right? Like we've done stuff in finance and commerce. We have some stuff planned for the new year in gaming. We have, what else? We've done some like defense adjacent type stuff. Earlier before that, we did some animation things. There's a lot of different sims, right? Like simulation is just very broad. It tends to be fiddly problems where there isn't a good way to do it without RL, and we can build fast sims. Approaching financial stuff. I mean, I don't have a finance background, right? I have an RL background. So in my mind, finance is just, it's like one additional application, right? And companies are not working with us because I'm a financial guru. That makes sense. You know, I've had a lot of people who like think that their problem is uniquely challenging, and then it turns out to be about as difficult to learn as Breakout. RL's really, really good at fiddly little optimization problems. Yeah, it is cool. I mean, look, it's pretty simple now. If you tried to do this stuff before Pufferlib, you'd be screwed, right? Like, you get 2 to 3,000 steps per second training, and that's just GG. So it's kind of because of the last 2 years worth of work and then all the research that went in before that over my PhD that we're now able to do this. So it's not like this is just simple, right? It's, we've worked hard to make it simple. Yeah. Star the puffer. GitHub stars go up. Puffer get big. I know exactly who that is. How's it going, Charlie? I remember that username. Or she, I got some of my own now. What the hell is wrong with this thing? It's gotta be something with trace, right? Hang on, I have an idea. What if I don't replay? Let me make sure I'm not breaking it in the process of tracing it first. Oh yeah, I think I owe you steak dinner the next time I see you. You had some good advice. Any good domain that you might suggest would be good for a paper in 2026? There are a lot, but it really depends on your experience. Like exploration is a big one, but the thing is, there have been a ton of papers on exploration, and pretty much everybody frames it wrong. So, yeah. We have some plans for that in Puffer 5. I gotta get Puffer 4 done first. Double check one thing. Share any of the advice? Yeah, the scoping thing. Man, the scoping thing helped for sure. That's the main piece I use so far. We've been doing quite well lately. Honestly, the thing like The main worry at the moment is just the pure technicals. I'm gonna get running shoes for 500 Navy SEAL workouts. I get Brooks Adrenalize, I think. Brooks Adrenaline or Adrenalize, one of those. That's what I use. They're pretty good. I'm not really doing a super heavy running block at the moment. So before I left, I put like 5 pounds back on, but a lot of strength back on after the cut over the summer. So before I left Maryland, I pulled 405 raw, and I ran a couple different times. I ran a 6:34-ish mile. Decent-ish 5K times. I haven't done distance in a bit though. So distance is going to be a few weeks of training to get back into. I'm not going to do that until over the summer though. I'm trying to put a little bit of weight back on while I'm in Florida, since I have this ridiculous gym 10 minutes away. Well, I'm not breaking it with the graph capture. So it's literally just somehow replaying this graph. This doesn't work. Think how this makes sense. How would you frame it since you're not writing papers? That's not what I mean, Jess. Not like to get it accepted. I mean to be valid. Okay, element 0 of tensors does not require grad and does not have a grad function. That's so weird. It's like we capture train forward graph with train forward call, right? Still curious? It's a longer conversation, and it's going to be something I really dig into in Puffer 5. I think that they're two different parts of exploration, one of which is actually probably solved implicitly, and one of which has not been isolated correctly before. This is weird. Element 0 of tensors does not require grad. Are you not supposed to trace the forward pass independently like this? I mean, what happens if hang on, I have an idea. Guys, if I just trace the backward pass, right? Well, if I do this, and I just decide, you know what, you're going in, train. You're going in here, right? New value, and I'm gonna have to pass a bunch of crap to this, I think. Compute is a very big thing here, but it's not. Compute is a big thing because everybody's writing slow code. We're not compute bound at all. We're like skill capped because everybody's written stupid slow code. It's like 100% own goal skill issue. Like the stuff I'm doing now is optimization after I've already made things 1,000 times faster. And so you don't even have to do this level of stuff. In fact, there was so much free perf. You could have made it 10x faster than everything was before without even really trying. And just nobody did. That's not true. A couple people tried a few things to make it 10x faster, but then they overcomplicated it. You really don't have to work that hard to make stuff 10x faster. Yeah. is kind of GG. Maybe. So I just take this and I put everything from this into pufferel. I think that's it, right? And then I don't have to worry about these output buffers being screwy. Like this. Let me not try to autocomplete, please. Okay. Advantages. File values. Parents. We also need to add some crap to this, which is going to be need all this stuff, right? Which mean, that's so annoying though, because I have to pass this. I guess we just do it for now, right? Advantage mean. Yeah, so everybody's been bugging me about this, man. I said I'm gonna do a stream because of Carpathy. I do not believe this shit. You can build a company in 10K lines, man. A really good one, actually. Hell, you can fix 10,000 good lines of code. Like, you can fix a lot of really major outstanding problems with that. Like, I genuinely think for this use case, I could probably replace Torch in 10,000 lines. It's fine. Smaller than 10K lines. So I have a project. I came up with a basic project that would take me a few days that I think can be done in about 1,000 lines. that I'm expecting. Well, I was gonna try Opus 4.5, right? That's in Claude Code, yeah? Because that's what everybody's telling me. And if it's good, hey, yay, I'm wrong. I will like consider how I can use the new tools. I'm going to be shocked if it is. It may speed you up. I can't explain it in English. It's like the other models at the least are wrong. I mean, they get stuff wrong all the time on the level of like, individual line, just wrong usage of stuff and not understanding how libraries work. So like they actually, in my case, they fail at even being good fuzzy docs. At least Sonnet and Grok 4.1 both fail at even being fuzzy docs half the time for what I'm doing. So we will see. I will stream the whole thing with 1K lines. I'll announce it as well, at least a day in advance, so that people can come tell me, oh, you're doing it wrong or whatever. You're not prompting the language model correctly. Because I want it to be like unambiguous one way or the other. Right? I want it to be like completely unambiguous. That like I gave it a project where it should totally be able to work. Git stash if it messes up. Okay. I mean, I will try, right? Like the standard is this better than me just writing the code myself, right? That's the bar. And by myself, I get to include at this point my current workflow, which includes a really, really stupid model that's fast, that saves me mostly typing. Like this model here is, I don't even know, it's super Maven, right? It's probably like less than 3.5 level of a model. I don't know. And then there's I try to use models for fuzzy docs occasionally when they don't exist. I don't really use them to write chunks of code. So if it can do that, yeah. So Charlie, I plan on, it's a 1,000-line environment. I have several environments worth of sample code. I have the entire puffer repo, but like it doesn't need to use any of that stuff, so it's very self-contained. The only dependency is for the graphics, which will be Raylib, which is a very well documented and widely used project. So it should be the perfect use case. I'm expecting it to flop terribly. We shall see. Is Claude Code, is it supposed to actually be able to like compile and run your project to debug stuff, or no? Or does it only do that in Python? Like, because I'm assuming at the very least, if it doesn't do that, there's just no chance. So it has to it would have to be at least compiling and checking the output of C. The agents can be, you need to whitelist the commands, I see. Yeah, see ya, man. Wrapped Vizdoom. Yeah, Vizdoom works. Oh, there's a very low resolution option in Vizdoom that if you turn it on, you'll get even faster. Okay, I will make sure I let it do that then. to accidentally ARM-RF your computer. Yeah, I've heard it likes to do that. That's not sketchy or anything at all. Copy, return. Okay, so this should be fine, right? So everything is copied in. And then we don't need this. 8 M's. I think you can get up to like between 100 and 250,000 on Doom. There is actually a really old, like, janky Vizdoom binding in Puffer. If you look, there's a comment that tells you where it is. Like, it's a niche thing that I had to find in the source code. There's like basically a potato resolution, and it saves you a lot. That's what you want to do. Use cursor, not Claude Code. Yeah, but can we agree that, like, if I do this experiment with like Claude Code and Opus or whatever, like, am I still going to get people saying, "Oh, you should have used my favorite model instead"? Because at that point, I think that people are just imbeciles, right? Like, oh yeah, we get to split hairs over like which of these models. Like, you didn't use the model that came out last week. It's like, well, but you've been saying that this stuff is good for the last 2 years, so like, you know, yeah, Claude Code is fine, whatever. I'll be shocked if it's useful. Like, if you're specific to the boilerplate. Well, exactly, but this is the thing, right? Like, look. So that guy, this is not what I'm talking about, okay? I'm talking about this shit. Like, my whole feed has been this fucking tweet. And people like, oh yeah, like, if you're not using these for your code, you're trolling, blah, blah, blah. That's not like, oh, it writes a bit of boilerplate, right? I guess if you spend all your time writing boilerplate, then yeah, it makes you way faster, but then you're just an imbecile. So, right, like, this is a very, very clear thing that it's saying, and it's not, oh, they're good for boilerplate. And my whole feed is like imbeciles retweeting this. I know the people retweeting him are imbeciles. We'll see whether or not this has any merit. I will be shocked. I will honestly be shocked. I'm setting aside a day in the next, I don't know, sometime after I finish CUDAGraphs to do it. I think it's mostly just lazy people who previously had no skills, who are just like happy that they now feel validated because they can type stuff in and the model tells them how smart they are and produces like some junk, right? and then like a few smarter people who've kind of gotten hoodwinked into this stuff. That is my expectation. Why would you have to say exactly, Jess? Like that's the only reason I'm gonna bother. Because I wrote a thing like, hey, if somebody credible tells me to do this, I will. Nobody credible replied in the affirmative, and then Carpathy later went and wrote this thing. So I get here. Line numbers, please. Okay, here's your stack trace. Right. Cool. So we gotta fix this. Let me use the restroom real quick. I'll be back. I missed the 300K lines of code comment. The thing is, I don't need 300,000 lines of code. Like, I can solve so many things with 30,000 lines of code, or even 10. I mean, there are real problems that you can solve in 1,000 lines of code, right? Like, most 300,000 line code bases are that length because the developers suck. Obviously, there are some real projects that actually need to be long, but I would say that most super big repos are just that big because the developers suck. It's like completely possible to write 10 times more code than you need, or even more. It's completely possible to write code that's 1,000 times slower than it should be, or even more. Happens all the time. All right, so what's this? So we have, this is the, we need obs and state. Why do you use layer norm? Because we tested it and it worked. I don't like it, Jess. This model here actually is going to need an RMS norm to be good. And I need to find a replacement for that because RMS norm is really slow. This is something I need to study. If anybody wants to go study it, that would be great. It's like small to medium-sized science project, I would say. Science side project. Pure experimental. It seems to be very necessary for this model specifically, because this one gets stacked deeper. Actions. Where's this? Oh, I did this dumb. Hang on. Graph. Did I not initialize these? Let me just print all the sizes. Come on, let's get this thing done. Advantages, turn size. Okay. Screws up encoding. Elo goes up anyways. Yep. RL is very good. A lot of the times it can figure stuff out. This compiled, no? What are we breaking on? Oh, we're breaking on the capture? Let's just do this. Okay, so now we have sizes. Perfect. Where is it? Oh. Here we did it. Okay, so we got logits. These can get commented, actions. This. Log props. Advantages. Trial. Oh wait, advantages is, yeah, and then prio is just this. Yeah. And then FB values, returns. Good. So, that should be fine. I should print the D types to be sure, right? This one, how do I not have this? Oh, dummy. I've never liked TensorBoard. I think it's going to be 1B in Constellation in our next update. Constellation's our new thing. It's quite cool. You'll get to see the dev on stream for that in a few weeks, most likely. I don't think any of this is lightweight, man. None of them are good. That's why I made Constellation. It's like a different thing. But Constellation is not for live monitoring at the moment, it's for aggregate monitoring. Okay, this one runs. See? And now I want to capture. Oops, let's do get graph capture first. Let's not get ahead. Capture graph. Okay. See if we can capture the forward graph. Auto grab this. Why is this? Oh, I see why. See if this is traceable. High eval save thread. That's disgusting. Oh, well, hang on. No, this is right, isn't it? Dude, that's like incredibly obnoxious. That is incredibly obnoxious. Holy. Okay, this apparently runs at least. Because this is a capture. Can we replay? Oh, it's just not train? Hang on. Okay, I'll deal with that in a second. Let me see if this even runs. Oops. Oh. Why, hello there. That would be perf target if that number is real. If that number is real, we win. And I don't have to do any further optimization. I will just have to clean everything up. I mean, I'm obviously going to go bother like doing it with the optimizer as well, just because it's probably an extra little bit of perf. But the goal for this release is 10 mil. That would be amazing. I'd be so happy. I didn't expect it to do that much. I'm a little suspicious that it might just not actually be calling things, though. But you would get more perf back if it weren't calling it. Interesting. We gotta figure out what happened here. How this is breaking. So Okay, so this one here, look. We got our obs, we got our state, we got our actions, log prop manages, priorities, guides, and returns. Those all look good, right? We have everything that we would want there. Graph train state. So we get MB obs, state, MB obs, MB state. Actions, MB log props. Okay. C project with pi bindings. We have something sort of. So Eric, you're gonna really like Constellation. I don't think we have screenshots around, but you can go look in 4.0. It's a single file, Raylib for rendering dashboard that will handle, many thousands or tens of thousands of experiments worth of data and do everything in aggregate with like a whole bunch of different plotting options that is instantly responsive with no lag. And will be runnable in your browser as well. I don't have live anything in it, so I don't have live monitoring, but it'll be very nice. the entire thing. Is the entire thing. We're not going to count our 10 mil until we actually see it and train. See, now it's down to 7. Are we still replaying? No, we're not replaying though, right? No. Okay. But something happened here, right? Like ball. This is good, right? I mean, that's like, how did I break this, right? So we do obs to dtype and we state this is going to produce new value logits. This, let me give it actions, log probs dot two. Wait, 2. Yeah, because it doesn't write, so that's fine. File value returns deviation. That seems fine to me, right? That's weird. That is weird. What could have gotten messed up? These states supposed to be zeroed. What if I instead make them equal? Graph. Yeah, let's do it like this instead, right? See if that has the same effect. Okay, so this is still broke. Okay, so now we start getting confused and concerned. Because now I'm literally passing the action. Now, yeah, now the question is, did I mess something up? Actually, let's just make sure capture is not... I want to make sure this is not screwing us up somehow stupidly. Right? Ah, see, this is why we check things. Anybody explain? When we capture, it breaks. I'm sure it's not this. There we go. It's just not zeroing the grads. Okay. Now we get to do graph replay. Well, not yet graph replay, I think, right? We do this first. Let's make sure the copy version works. Still works. And now, graph version. But look, it doesn't optimize. Let's go check the obvious one. Okay, so there's hope. But I don't think that this was running, so I actually, yeah, this is probably not going to be as fast. I think this was too good to be true. What did I do? Failed. Eh. Oh. Man, that's so annoying that that happens. Forward. Alright. Now we try. This doesn't fix the, this compiled? Can't think of anything else that it would use, right? PPO. Yeah, and then this is back to the top. Okay. Forward graph replay. Yeah, but it doesn't optimize like at all. Just move. I'm gonna try something. I don't know if this makes sense, but I think technically, right? What if we do this? It's still not. It's still not not doing anything. We can capture the graph. Let's see. There is a torch tutorial, right? September. This is already true. I don't think this does anything. Let's make sure that we actually have it. Make sure that this is good still. So this still works, right? Decently well. Now we use this one. It should be here within the next couple days. I know it's been forever, but yeah, that's the situation. Because it got shipped to the farm, and I got there while I was on vacation, so now it's going here. Okay, so let me see what they're doing on this, because this is something weird. Okay, take this, static input, static target. Oh, I could see that screwing it up, right? Hang on, does that? But the trace operation, right? No, so we are capturing either way. The only difference is if we replay. The only difference is replay. versus trace. I think this actually might be it, right? And I think if this could be it. No, see, it doesn't work still. Let's just go back. Right here. And then what? Replay versus just train forward calls. It's the same thing. Why you not work? Go check the checklist. It's the fuse scan as well, right? Log codes and values, fuse scan. Quite a lot of things actually get used in here. Do we want to rule these out? These are both totally fine. Yeah, so I mean it's interesting. This gets used though, does it? This doesn't get used. Real quick. Because let's get a full assessment of this without the custom kernels. No, we can do like this. Oops. This. This. And this doesn't help. Hello, welcome. Right, we need to do. Alright. We're very close. As soon as we have this working, I think we should see quite a good perf improvement. And I think like this will take us to the finish line even already. This might end up letting us overshoot our perf target for the update. Well, I guess we have the RMS norm thing to still figure out. But, yeah. I'd love to get your thoughts on any of the messages helpful. Self-play with uniform random. Oh, self-play. That's cool. Yeah, I'd like to look at that. How could I learn to program? What resources could I learn with? The stuff around here is much more accessible than you'd find elsewhere for what I'm doing. It's still not super beginner friendly, but all of my best advice for programming, it might be a little early for you if you're new. All my best advice is on my X, J Suarez 5341, and this article right here. Again, I'll link it. Biggest classes of perf games. The large batch formulation is a decent chunk of it. The environment speed, the vectorization speed. There is now with the new version, right? Eliminating Python overhead, custom kernels, CUDAGraphs for launch overhead reduction, tons of asynchronous copies. It's like there are just a ton of them, man. It's the problem is that you kind of get a flat profile. Like it just everything is slow in the normal libraries. It's not like there's just a few things I can improve. Every single thing needs to be rewritten and tossed out. Yeah. That's the problem with it. Oops. This really it? Yeah, Yeah, that is cool. This runs. So here we have our train forward call. So this is like the super naive one. This has some of our optimizations, but not a lot. Yeah, you see it's much slower, right? 4.8 mil. Now this one, at least we have no custom kernels in this. My article, I would use it more as a reference point. Like, just save that article and read it every so often while you're learning to program. It just has all of my best advice for like not wasting a ton of time. Programming is a very poorly taught subject. And if you're taught it wrong, it takes a very long time to unlearn and relearn the correct way. Okay, so it's not the custom kernels breaking this somehow. Print the first wait maybe. That would be a good one to print the first wait. I mean, my advice is kind of in there, right? For that, you need some amount of formal resources from a course. I don't really know any great ones for beginners. I mean, I haven't been that in a long time. But like the course material, it's not going to teach you how to program well. Like it's there to teach you syntax, mechanics. When you get to lower level details of how an operating system works that at least are directly relevant, memory management. The point of the courses is to prevent you from like missing some gigantic important thing. Like for instance, I didn't know what hashing was when I got to undergrad. I just missed that. It's actually a well-known professor told me he had the exact same thing happen. So that's what that's for, mostly. Ah, man. Get like a protein shake or something, take a break. Let me try a couple last things here before I do, though. I'm just hungry. I haven't eaten anything yet today. Some like snacks or something in the middle of the day. Why the hell's this shit private? It's not a cheat sheet of syntax. If you're brand new, you kind of need to be like, you can't just be like 4 iterates. Like, that's not a useful cheat sheet. You need to be taught the basics of control flow, Boolean logic, function calling. And there are some basics. So this thing here, right, this is borked. This doesn't change at all. Why could a graph do this? So close to having it. So, I mean, we can see here, this is the correct example, right? The weight changes a whole bunch. And in the incorrect example, at least now we have a check. Still doing tinygrad stuff, man. It's a good library. I like a lot of the things. The way it is at the moment, it's going to take me some more work to figure out if I want to like pop kernels out of it or whatnot. I'm doing CUDAGraphs at the moment because right now we're mostly limited by launch overhead. And like, I can't just use tinygrad because like tinygrad won't let me optimize to the level that I'd like. I think if tinygrad were just written in C, I'd be able to just use it, but it's not, man. Dang, I thought that might actually work. Teh. Exactly, right, Eric? Like, if these things worked, the world would look very different immediately, right? It's like, I've invented teleportation, or it's like, well, why are you taking a plane then? uh, it's dumb. Alright, I'm gonna use the restroom real quick. I gotta get myself something with calories in it so I can continue on this. The current bug, for anyone wondering, so we have it that you can trace the train loop. Um, the traced function, when you're not calling it with capture, works correctly, but then when you try to replay it, the parameters don't change. So something got screwed up here. I don't know if it's like a pointer's getting overwritten or something. We will see. I'll be back. Okay. Got 60 grams of protein. Hot chocolate. I swear, the last 2 days of dev has been like, write 5 lines of code. Encounter evil bug of doom with no error message or stack trace. Isolate evil bug of doom. Fix evil bug of doom. Double check. Yes, there were literally no docs, no examples, no anything that I could have possibly referred to fix evil bug of doom. Ported 100% all the way up to the main menu. Let's see. Oh, cool. Wait, what are you doing? Are you like looking at the assembly and trying to port it to C? Scroll up. Yeah. Interesting. Assembly to Zig. Zig is fine as well, whatever. Cool. I mean, if you actually do get this thing to be like fully implemented and fast, it will be very cool. Like, if you can get this to the speed of the actual puffer ends, this would be a very, very nice one for RL. It would be awesome. It sucks that there's no way to get like a general purpose emulator that fast still, but even just having like the one Pokemon game would still be amazing. Like, that'd be a really good end. Mike is a little quiet. I was leaning forward. Protein hot chocolate. It's like 60 grams of protein. IRB assembler. I mean, that would be very big. I will await your progress. Big cup. Yep. Okay, so last evil bug of doom for a while, hopefully. You know what we can do? I want to try something. Zydus for Pentium? What does that mean? Be back when we can battle? I get. I'm not enjoying my graphs. This is miserable. But I am fresh off of vacation, so I can endure this for a little bit. Yeah, Jess, I don't think there's a way to do that. I think you're way better off just trying to make it substantially less work than it is now. Like, we technically have that in the sense that it'll just flatten it and run something for you. But making one that's actually good, that's, like, not really doable. At least not efficiently. There are tokenizer type approaches. They produce very inefficient encodings, though, usually. Because it's like context specific. Okay. Next, what we do is, right, I was going to print out, wow. We could definitely do like a which ones are hot or whatever visualizer. There's a lot of stuff we can do. See if this prints the whole thing or prints the address. What I missed? Fighting CUDA. Dot data pointer. Okay. So now, right here, one breakpoint. The careful viewer may ask, what the hell am I doing? To that I say, I'm trying to see if the friggin' memory address moves. Alright, so before I capture it, and then after I capture it, okay, so this is our initial memory address, you see? Oops. It doesn't move. The memory address does not move. So then how the heck is it screwing up? I forgot to increase the key repeat speed on this machine. I was wondering why it's so freaking slow. Where is it? They got rid of it apparently. That's annoying as hell. Oh. Look up the command later. Oh wait, this is... I wonder if you can do this. Maybe you can't clip. Same shit. Alright. Law stop backwards. It's gonna make a really aggressive update. That doesn't get changed one bit. know what? I'm gonna try something else. You. Attach. See if it changes during capture at least. Six, 7, 5, 6, right? All right, so here's my question. How? Right? Oh, you know what? Can you load? I actually don't know. Let me just try something. I had an idea. I think I just misunderstood how the graphs work. That is still an evil, evil, evil bug if I'm correct. All right, so what we're gonna do. I'm making progress. 67, what? Okay, so how's this not changed, right? No. I do not know Zoomer meme. I am old. Very old. Ancient, in fact. Phone screen time today? I literally don't even know how to do that. Yeah, I don't even know where the hell that is. 32 minutes. You'll know I've really made it in life when I no longer own a phone. All professional inquiries are to be directed by carrier pigeon. What if I just run that function once, right? If I just do like forward, was it train, forward call? If I just do this thing, what happens? Evil Bugadoom. Evil Bugadoom. Or Vim skills. I use Vim the way I use everything else. Like, I don't use all the fancy features. Actually, the biggest thing is I need to fix, this is a new machine. I need to increase the key repeat speed. That's about it. Open front end. Make sure that you think about the obs and action spaces, Jeff. And what about chess? I want to see the chess thing work. Okay, look at this. Okay, look at this, guys. So this is what I was looking for. If I run this function, okay, the value changes. I'm going to put one more here just to show you. I think we can figure it out just from this. Okay, good. We need the soft list stuff, man. Wait. What? What? Huh? Excuse me? What? Huh? This thing is messing with me. Oh, it's messing with me. Seeing what? Mm. Mm. Okay. Well, this is bizarre. Completely bizarre. I think we just accidentally figured it out. Which is so bizarre. So, let me see. If I just don't do this, does it fail? Is it like not warming up properly somehow? This didn't work before. Maybe it was this and I messed up the test. Oh, okay. We found it. We found it. I don't know how I messed it up in the test earlier, but yeah, it's this. Okay. So apparently these coefficients, these just go into the CUDA graph. And you can't change these at all. Okay. For IDE, this one, Neovim. That's so funny that I just post this thing and this is of all things blows up. Blah, 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 blah. It does not produce new code. What the hell is this? Wix. cloud-based web development services. The fuck? Oh. And I'm supposed to take... Yeah, no thank you. Whatever, man. If you're enjoying the suffering through CUDAGraphs stream, go ahead and star this puffer. He likes stars. You need to be fed right here. This number go up. Feed the puffer. Double check one thing, and then I will implement the rest of this fix. And then it will work. And we shall be happy. Hey. Okay. So, how we do this? This mean and standard deviation this is actually now a broad question. Let's actually just make sure before we break anything else, used. Yeah, and Vim. That's not good. We do this one at least. This one not getting traced somehow. Budgets, new value. Yeah, that's 9 mil though if we get that. So without this one, with 8. Okay, so that runs. So now we gotta figure out what the heck. Okay, so you can't have these scalars apparently. Cool. That's a pain. So what do? We convert these to GPU buffers. Convert these to GPU buffers. We're gonna get a full prototype of this done today. These guys, running all these params. Okay. We'll double check these, but probably be able to fix this. Okay, puff around. Now these ones. Let's double check this first. Okay. 8.7 mil speed. Now we need to get the advantage. Was it mean and whatever it is? Advantage mean. Just leave this on this buffer. Attach. Just attach it. Shouldn't get it grad. Why does it not get used? Wait, what? Advantage normalized. Ew. Let's see. So this one probably still runs, eh? Yeah, this one does. Okay, that's one. We're gonna do that as a separate stream, crit. We're gonna do that as a separate stream. Because of the dang Carpathy tweet. Yeah, okay, this is why this runs cool. $9 million, guys. 9 million. Almost there. I'm gonna make a quick commit. Alright, so let's figure this out, alright? I have a hypothesis. Here's the hypothesis. Alright. I bet you that if we just do like this, we do like this, all we have to do is like that, right? Now this fuse PPO loss needs modification. Right, this needs modification. Let's popular for ASV UV. Results were great. Cool. Glad to hear. Yeah. I've seen you in chat. My brain is currently CUDAGraphing at the moment. We are on hour, what is this? I did 10 yesterday. So this is about, we're entering hour 16 in the last 36 hours of CUDAGraphs. That should give you an idea of the vibe at the moment. Productive, but brutal. I mean, this is actually kind of impressive. No, the more I'm thinking about it, if we're gonna hit 10 mil in float 32, that's pretty freaking good, right? I think that B float's still unstable for now with this, but like, we hit this in float 32 and then some numerical stability work down the line. Maybe we get 16. Good to see it. Pretty good. Ugh. Blech. I have to take a short intermission relatively soon. Oh, the backwards. Messed it up. Hey, what the hell? Oh, wait, no, this is not. See what this saved kernel is. Stuff is tricky. Okay, this is how it is, look, you see? So I think this is okay. Doing here. It's supposed to be. I just have to figure out how to like pass this back, right? Okay, how do I do that? IO. Okay, so this is the forward pass. And then you get it. Save scalars. Oh, you know what? You can just put stuff in here, can't you? So can I just do, what if I just do this? Objects, returns. You can just do like this, right? What we do. If I do it this way, it's just a tensor, you can save it. That does compile. Oh, I know. I know what we have to do. That's right. Actually avoids a graph break, funny enough. This could be a no graph break train loop. Nice. Is this the full thing? I mean, there's some sketchy bits with it, but I think this is it. Let me see. Yeah, that's a replay. And yeah, that's the fused loss. Okay, that's the entire train loop, guys. That's pretty cool. What do we call this? I have this commented. We're gonna break it. This will eat a few SPF. Actually, we'll get rid of this. Well, I think this can be a higher perf. We'll try this. If this doesn't break, we're gonna be happy. That train's 8 point. Oh, there you go, 9 million SPF. Okay, I'm gonna run profile and I'm gonna commit this. I know. I'm gonna take a quick break as well. And then I think that the plan is I'm going to be here until about 5:30 maybe. I got a thing to get to by 6. 20-30 minutes away. Yeah. Okay. As long as this finishes, I'll leave this up on the screen, and I'll be back in a second. A few minutes actually. Look at that. There's still a ton of launches. We're down to 10K. We'll figure out why there's still 10K. I'll be back. We'll get our 10 mil. Okay. Two hours remaining. 2 hours remaining. Let's get rid of this bot. Oop. All right, what do we have here? CUDA device synchronize. 641 graph synchronizations. Oh, I know what that's from, though. That's fine. CUDA launch kernel. Way lower, right? So we're saying there's 366 ms CUDA, 400 ms CPU. What is CUDA stream for here? Device synchronize. What happens without the CUDA device synchronized? All right, we're going to try a couple things. Okay, so notably, right, this is not faster. It does break training, though. Okay, I'm going to actually toss this Nick Rock in a second, because launch kernel. One device synchronization. You see that? Beautiful. Okay, so what happens? What happens with this? So one device synchronization. And before we had CUDA device synchronize, 57 ms CPU. Okay. So 57 ms CPU. Now we have 8 ms CPU. We did drop like 20-ish ms. But I think at least a good chunk of that time is phantom. Now, what is CUDA stream query. You saw it? What? Isn't this, wait, command buffer full? Actually, I'm gonna just chuck this into Grok. I'm confused on this. Does these add up? Because it's 370 ms, right? So this is 190. So this is already above, this exceeds the, oh wait, 377 ms? Yeah, this is all already over 400 in these lines here. Let me try one other thing. Try one other thing. All right, guys, hang on. Let me try something. We're going to disable the env, and we're going to see if that cleans up the profile. Oh, we can do a couple things actually with that. One device synchronize will be awesome, though. Okay, so how much faster does it get with no env? Look, it doesn't actually get faster, meaning that it's full async, we're not really bottlenecked. Maybe a few 100,000, maybe. Not major though for the whole env, which is cool. And then we're gonna do profile. And then we're gonna see if the CUDA stream query is shut up, because I think those are all coming from the env and they're being done on thread and then they're getting added up. We will see. List. Okay, so this is a better profile. We still have the CUDA stream query as this, like all the overhead. List of all latencies. Well, I have to figure out which of these is overhead. They still don't add up, right? No, wait, maybe they do. Let me just look if there's... See if that does anything for us. See, this still has, this is the full. Interesting. Let me see if this adds. Do we have full step? 5. So wait, we got 5 of these. And then this is what, 640 MF? Does that count? I don't think so. It's 4 mil. Yeah, this profile overhead like mad. Because everything's false by default. Well, one thing we can do is, how fast does this run? That is actually close to the real runtime, right? all in CUDA query. Maybe this. Maybe we need nsys. Okay, here's this. We get element-wise kernel. And now we get like a pretty clean, we get like pretty clean long tail, right? With fuse scan actually being element-wise with fuse scan. Copy, a little bit of copy overhead. Actually. Oops, it's not desktop, I get containers. There we go. That's full speed. Oh, and it doesn't exit cleanly. Hang on. Let me fix that. It needs to exit cleanly. Let's see how this goes. See if I can do none. Doesn't exist, good job. Hmm. Oh, that was actually close here. There we go. Get a good profile, come on. I need a table. Does this exit cleanly? I don't think so, right? This should be done. Oh, cool, you can just hit Control C. Huh. Can I just do see if this exits? Yes, it just doesn't exit cleanly. We could do no threads, I guess. Maybe that would help. I mean, we need to get some profiles. And I think that the torch one is just way too much overhead. The hell is this thing stuck on? Hmm? There's literally nothing interesting on this. Not exit cleanly. But maybe, hang on, maybe we can do this now. Maybe we can do this, hang on. Okay, there we go. That's nice. Oh, did I do something just incredibly stupid? OS runtime. What's this? Is this real data? Oh, let's see. Heck. So why is that not hmm? Hey Fabio, welcome. This Joseph. Me very tired, fight CUDA demons. I'm being just a massive goober, but whatever. Okay, we'll try this. Oh, there we go. That's a proper graph. Lovely. Oops. That worked. I actually should know how that works, but I don't. Yeah, I should totally know how that works, but I don't. I think it's like second stream, but I don't know how that actually maps. Basically. See if that does anything. These are nice tables. This is exactly what I want. Try it again. That's so funny. Profile out. There we are. Yo, where's my output? Oh, there it is. So, Grok didn't work, but I can make use of this. Unless it's messed up. No, we got it. It's all right there, right? CUDA launch kernel. CUDA graph launch. 92K, 98,000 kernels. Oh no, this is actually fine, right? Actually, no, these add up perfectly, right? So nanoseconds to nanoseconds is E12, right? No, 1 billion. Nano SI. Yeah, it's a 1E9, right? So wait, this is 4 seconds. What's this one? 0.4 seconds. Okay. So let's do something about this. See how many epochs. And I want to see if this makes sense. Okay, 229 epochs, right? We're trying to monitor how many kernel launches there are. Okay, so we have we need to sort it different. So we need CPU time. Okay, so this is, look, 10,000 kernel launches, or this is 5 epochs worth of profiling, 5. And what did we say that there were? 229. So we take this number, we multiply this by like 40-ish. So we should have somewhere around 400,000 kernel launches. And what do we get? Oops. We get, yeah, 400,000 kernel launches. But then wait, 400,000 kernel launches. Average NS. That's ridiculously high, isn't it? No, wait, that's 12. That's 12 microseconds. So wait, 12 microseconds. Does that math? It does, right? That does math. Oh, but what is this? Oh, these graph launches are so expensive. This is interesting. This is 1 second. Can I sum these easily? I don't think I can. But, oh wait, 17, 1.4. 8.2. CPU plus GPU. Scan forward. Is this still profiling everything though? This is. Interesting. inside Python. So what, like it's called from Python? You can already run this on Python though. It's just gonna profile the internal calls, right? Well, this is way better. 35 micros. Now we have, what's this? This is 7 seconds spent on. So there's no way that this is actually 7 seconds. This adds up to the program time exactly. It would be bizarre. Now, I no longer see native unrolled element-wise vectorized gather kernel. I no longer see my graphs in here. Yeah, so my graphs, unless it's one of these, unrolled element-wise kernel, I wouldn't have done that, right? Pretty much, yeah. I'm trying to figure out what is launch overhead and what's real, and it's kind of difficult, you know? Okay, so you see, like, this is... before I grouped by graph, I saw individual kernels of mine, but like now which of these are actually my graph, right? Perfect. What view does that give me? I want an aggregate. Does this give me aggregate? I don't want traces. I just want average kernel timings. And like graph timings, right? Timeline viewer? Yeah, I don't want that, dude. That doesn't help me. This has got to be one of my graphs, right? Native GPU kernel impl. This has to be one of my graphs. Presumably these are all. You should be able to name them, right? Is this display? What display? This is NSYS. No, man, this is NSYS. The shell script is just like is just an NSYS run. Yeah, I'd like to be able to annotate. That's what I want to figure out. That would be helpful. Label graph or sys. CLI, yeah, it is. It's way lighter though than Torch's profiler. I don't know what the hell Torch is doing. There's got to be a way to label it, no? Like this is a really basic post. Begin capture. CUDA backtrace. What's that do? Hull stacks. Well, what I want to do, dude, is I want to label I just want to label my graphs, so I can see. Let me try this. Like, you see what I'm trying to do, right? Like, I just want to have visibility on everything. So, now we have things chucked into graphs. I want to know what's my launch overhead, what's the time spent in graph. The idea is just like nobody actually really profiles their code in RL, like ever, right? Like nobody actually knows where the time loss is. Because if you do like the Python profiler, there's so much overhead in that with RL, you're literally just measuring the profiler. Um, it's actually very difficult to figure out what is profiler overhead versus what is real. It's difficult to understand like overlapping of launch calls versus anything else. Can I just annotate this thing? I just do like this. in the way of owning the language surface. The compiler as well. I just need the profile, man. It's really not that complicated what I'm trying to do. Okay, let's see if this does it. Oh, we are at like 9 million SPS though, so pretty good. This should be available, no? Oh. Buffer out of bounds. Built into the language. You don't need to build that into the language though. Memory access. I don't really have that many like language level problems, honestly. Supposed to be. So the lack of transparency with profiling is just lack of docs and possibly small lack of features on tools. There's nothing language level that's the problem here at the moment. Is this? Maybe this is included? Overworld rendering is in. Awesome. What about the base sim speed, man? Like, the rendering is awesome, but the most important thing is the tick speed, right? Because like we can technically train from state. You'd have to get the state up to, well, you have all the cores on a machine technically. The problem is the factor of 24 that comes from the skip in that game. So like 24 million aggregate would give us 1 million step per second sim effective. It needs to be quite fast. I think it's definitely possible. Like, I don't believe looking at Pokemon the game, like there can't possibly be that much stuff going on under the hood that's not for audio and rendering, right? Because you don't have to sim that. Do whatever we want. Yeah. It's a factor of the emulator. No, it isn't, right? No, you have to fundamentally like it's an old game. Presumably the tick system is hard coded, right? 24 emulator ticks. Yeah, but aren't those games written that way? Like, I'm pretty sure those games are written to be very tied to the tick rate, man. I could be wrong, but I don't think like they're not in any way tied to real time, as far as I know. I think they're tied to that tick rate. That was a number, Peter. No. So the 24. So I understand that the 24 is arbitrary, but like 24 is it's the frame rate. It's tied to the frame rate, right? Like it's the amount of time. It wasn't for one button press. I thought it was the amount of time to cross one tile, wasn't it? Yeah, I'm still alive. I gotta go in like 20 minutes, but I'm live for now. I mean, regardless, it's the real time speed is the thing that ultimately matters because for that game, you're taking actions at a rate of 1 or 2 per second's worth of real time gameplay. Like you can't just take actions more frequently and have it be higher SPS, right? Let's see if this does anything. With the green. Yep, it's not like fully from scratch, man. It's still a direct port. Or the rendering. Mm. I guess technically, yeah, you could make it so that instead of the agent moving like a small distance in one tick, it moves a bigger distance. That would be a pretty big win. It would probably mess with other things. Like there are things you can do. I think you can make it fast enough though, anyways, frankly. Like you can definitely get 24 mil per core if you want to, and then have it be super fast. Like, there's not that much going on in Pokemon, right? Like, what do you actually have to process every tick under the hood? Not very much. Yeah. So I don't think that you really have to do very much to get it fast. Like the hard part is obviously that it's got to be ported. I actually don't understand why the emulator is so slow either. I don't understand enough about emulators to know why that thing is so slow. You know? Oops. Why they're all so slow, rather. To handle all the instructions. Large switch case. Why is it a switch case? Let me think. Can you not just like map the instruction to an index or whatever? There's gotta be like, can't you like store them as indices or something? There's no way that you need to have it be a big like switch table, right? It should just end up being an array lookup, no? Hmm. I'd have to look at it as to like why that can't just be, because like the standard trick is to just turn it into an array, no? Okay, this runs. See if this annotates now. Oh, it's not fast enough. Hmm. Yeah, I don't know enough to say. I mean, you know, I'm not going to be the type to just say, oh, well, it sounds like it can't be any faster without knowing. But it is a fairly well studied area, I'd say. But, like, I don't know. Maybe there's something smart you can do. Who knows? I'd have to at least spend some time with it. Where are my tags? Open the. It's going to be a mess, no? Yeah, what am I supposed to do with this, man? Query run. Okay, that's a fair, fine idea. Um, okay, there is something in here. Rollout graph. There's got to be a command, no, to get it. Literally open the file, select. Well, I don't know how it actually stores the logs, man, but like, I should, is there not something I can do? NVTX sum? Oh, look at that. That's great. Look at this. That's awesome. Check this, right? This is a tiny amount of time, though. Did I read this wrong? Okay. Does that do anything? Okay, I think this is what we're gonna have to do next, right? This will be the next thing. But the the result from today is quite good. So we got upwards of 9 million steps per second. We're very close to the end goal here. We need to do some profiling to understand the remaining bottlenecks. We're able to get the entire training, the entire training of the whole network with one CUDA device synchronize, excluding the environment syncs, which are going to be able to not be full syncs. So I'd say this has been quite productive. 9 million steps per second, though. We're almost there, guys. Almost there. If I can just add some amounts of annotations that let us monitor a few sections of the code when we have a profiling mode on, and just get us a nice little table with the major overhead categories, we should be able to optimize very nicely. I've got to go because I got to get ready. I got to go get to dinner. I got to go pick somebody up as well. For folks watching, thank you for tuning in. I will probably do another stream tomorrow, pending things. If you're interested in my stuff generally, I stream all my dev, all my research pretty much. All this stuff is open source at puffer.ai. If you are interested here, star the repo, feed the puffer star. He likes stars. He's hungry. It helps me a lot. Discord if you want to get involved. Nice community here. You can follow me on X for more RL content, including announcements and such.